Hello, General Biology, and welcome to the third in the screencast series for Section 2.1, Chapter 2, The Chemistry of Life. And you'll recognize this screen as the screen that we left off on, and we were talking about what a compound is. And basically I was telling you that it was a list of ingredients for that compound, or a list of elements and how much we need with that. So what I didn't say is what we do for this list of ingredients that you're seeing here. These are chemical formulas. And the chemical formulas tell us how many atoms, how many elements of each atom we need to make that particular substance. So we were just leaving off with sugar, and we said that's glucose, and it needs 6 carbons, 12 hydrogens, and 6 oxygens in order to make that up. Now, let's talk about a couple of other things here, because I want to go with the examples that are on your PowerPoint here. It says the formula for table salt is NaCl. Notice that there's no numbers after this, and that indicates that the elements that make up table salt, or sodium chloride, is actually a 1-to-1 ratio. There's 1 sodium to 1 chlorine. So we don't always have to have numbers after that. But here's what we need to know. When we have a compound, their physical and chemical properties of a compound are usually very different from those of the elements from which it's formed. Now I'm going to tell you, I always ask a question that relates to this on the test. Always. So please make sure that you know that. Okay, so let's just take a look at water first before we go to the example here. So hydrogen. Hydrogen is a gas. That gas, telling you it's a gas, describes its physical property. I'm going to tell you that this gas is flammable. Okay, that means it lights up on fire. So that is a chemical property. And that's what hydrogen is. Oxygen is also a gas, and it's also flammable. Okay, so both of these will light up in fire. But if you have H2O, 2 hydrogens and 2 oxygens that come together, the physical and chemical properties of this water is quite different than that of the individual elements. Water, we know, can go in the form of a liquid, there's that line again, solid, or a gas. Okay, so we've seen water, we've seen ice, and we've seen steam. Okay, that's still H2O. So that's the physical properties. And guess what? The chemical property is it can put out fire. So here it is by themselves, they're flammable, but this can put out fire. Okay, so let's go back. I'm going to erase this because I want to talk about that sodium chloride. And let's talk about that sodium chloride here. Sodium chloride, NaCl. Sodium is silver. So is silver a physical or chemical property? Okay, it is the physical property, so you're correct. It's silver, and it's explosive in water. So it's something that you don't want to consume. Chlorine is a green gas, greenish gas. So is that the chemical or physical property there? You're right if you said physical. And it's poisonous. So would that be the chemical or physical property? And hopefully you said chemical. So neither one of these by themselves sounds like anything that I want to eat, but when we put it together, we get table salt. And it's something that we season our food with and we cook with all the time. So it's a white solid, it dissolves easily in water, it's not poisonous, and we need that table salt in our diets. All right, so let's talk about how these elements get held together, and they're going to be chemical bonds. So I kind of answered that question there, what holds elements together. Since we talked about the electrons, protons, and neutrons, do you think that there's some kind of attraction or force that holds them together? And if you said yes, then what type of forces or attractions make these chemical bonds? So that's what we're going to look at here with these next two key concepts. So here we go. Atoms. I'm trying to think. So we learned about carbon. All right. Carbon, we found out, is electrically neutral, and it's called carbon-12. And it has 6 protons, and I'm going to put 6p plus for protons. It's going to have 6 neutrons, and it's going to have 6 electrons. Okay, so that's what it has in it. Okay, so when we think about, well, how do atoms bond? Do you think they bond by the nucleus? Or do you think they bond by what's spinning around and orbiting outside that nucleus, the electrons? Okay, not sure? So let me ask you this. When you shake hands with somebody, do you feel their skin, or are you in contact with their bones and their muscles and their blood vessels and all that gooey, gross stuff? Hopefully you said the skin. And is the skin on the outside or the inside? It's on the outside. So when there's chemical bonding that takes place, the chemical bonding is going to take place with what's on the outside. And the electrons are what is on the outside. So a bond formation involves the electrons that surround each atomic nucleus. And the electrons that are going to bond are going to be the ones that are in the outermost energy levels. So remember when we drew that carbon, you saw that it had 6 protons and 6 neutrons. And then we had two electrons that were kind of spinning really close inside. And then there were 4 other electrons that were spinning around the outside. Okay, the ones that are going to be bonding are going to be these outermost electrons, and they are called valence electrons, because they're the electrons that are in the outermost energy level. Each one of these is considered, this is one energy level, this is another energy level. And we can have multiple energy levels that the valence electrons can be in. So we have 2 types of bonds that can form between those valence electrons: ionic bonds and covalent bonds. Now the way that I remember these is kind of elementary, but I think of ionic bonds as the kids that don't share their toys. They steal toys. So this involves a transfer of electrons. Okay? Covalent bonds are like the kids who like to share their toys. And this is a sharing of electrons that take place. And we're going to talk about how we know whether it's going to be an ionic bond or how it's going to be a covalent bond in a little bit. But what we need to know first is what needs to happen in order for chemical bonds to form. So the first thing is something that's called the rule of 8, or the octet rule. And one of the things about atoms is they want to be stable. They want to have a nice balanced spin. And if they don't have an even number of valence electrons on the outside, then the spin can't be balanced. So the way that they get stable is to have in their valence a stable octet. They want to have 8 valence electrons. If they can't have 8 valence electrons, then they want their electrons to be able to pair. So this is the rule of 8, the octet rule. And that's what we think about when atoms want to bond together. So I like this illustration that we have that I put into here. So an ionic bond, we're going to take a look at this first, is a bond that's formed when one or more electrons are transferred from one atom to the other. So if it's being transferred, that means that one atom is going to lose an electron and another atom is going to gain an electron. So when you lose something that's negative, since electrons are negatively charged, when you lose something negative, the atom that loses the electron is going to become positive in its charge. And the one that gains the electron is going to become negative in its charge. So the elements are no longer known as elements because they have a charge to them, and we call them ions. So let's take a look at that chlorine again, chloride, sodium chloride, that table salt. First of all, anything that ends in IDE, and I like to ask this question on a test too, indicates that it bonds ionically. So sodium chloride, that means it has a tendency to give up or lose an electron. Fluoride, bromide, iodide, okay, all of those, anytime that you would see IDE in the description is going to be an indicator that it bonds ionically. So let's take a look at sodium. Sodium here has 11 protons, so that's its atomic number. It has 11 neutrons to make it neutral in its charge, and to give it its atomic mass. And then it has 11 electrons to make it a neutrally charged atom. Chlorine has 17 protons in its nucleus, 17 neutrons in its nucleus, and it has 17 electrons in order to make it an electrically neutral atom. But what happens is, notice in the valence of chlorine, chlorine has 1, 2, 3, 4, 5, 6, 7 electrons. So it's not totally balanced. Sodium only has 1. Notice that one right there. So because the valence is more electrically charged, negatively charged in the chlorine, it's going to cause this sodium electron to be transferred. So here we had 1, 2, 3 energy levels. When it transfers, we only have 1, 2 energy levels. So now we have 11 protons, but we lost an electron, so that's -1 or -10, and that's going to give a +1. So sodium is going to wind up being positively charged. Now the chlorine gained that electron. Notice it has 18 now instead of the 17. So because it has 18 negatively charged, it's a negatively charged ion, and chlorine is written with the negative beside it. And that's what will happen when ionic bonds form. Okay, we're getting close to the end of the screencast. Let's stop here, and we'll talk about covalent bonding in the next one.